Hello, welcome to Naming and Drawing Functional Groups. Today we're talking about aldehydes. An aldehyde has a group on the end of the chain. Either end, it doesn't matter, could be both ends, but that's the maximum. It can't be in the middle of the chain because a aldehyde group has a carbon double bonded to an oxygen with a hydrogen on one side. So that takes up 3 of the carbon's bonds. It only has an option for one more bond here to the rest of the carbon chain, and that means that the aldehyde can only exist on one of the 2 ends of a parent chain, or on any end, depending on how intense the parent chain gets. It can only be on the end. When we have a name of an aldehyde, we will know that it has an aldehyde group because the parent chain will end with an Al ending. So if we look at the word aldehyde itself, it has Al in it, and that's how we can remember the ending of our parent chain is Al. So if we look at the parent chain, it is heptanol, and hept is 7 carbons, so I can draw out 7 carbons. It has An in it, meaning they're all single bonded. And if we have the Al ending, that also means that we must have an aldehyde group at one of the ends. I'm just arbitrarily choosing the left side. Wherever that aldehyde is, that becomes your carbon 1. So we can name and number the rest of the carbons, and then we can also add in the other groups that we have. We have a 4 and 5 dimethyl, meaning on the 4th carbon we have a methyl, and on the 5th carbon we have a methyl. Methyl meaning that group has 1 carbon in it. The other carbons can get a bond for hydrogen to fill their 4 bonds. The aldehyde already has 4 bonds, so it can't take another hydrogen. That is how you would go from the name to the drawing. When you're going from the drawing to the name, we're going to number our longest chain to be our carbon chain. In this case, it is 2 carbons long. The prefix for 2 is eth. So we know that our carbon chain, our parent chain, is an ethane chain. However, we do have an aldehyde here at the end. So we're going to change the E ending to end in Al instead. We don't need to show the location of that aldehyde being on carbon 1 because the aldehyde will always be on the 1st carbon. We've got another example from drawing to name. In this case, we're given a line diagram. I can see the aldehyde is here on the left side. That will be number 1, 2, 3, 4, 5, 6, 7, 8. I could have gone up this branch. That would be 4, 5, 6, 7. That would give me a lower number for the parent chain. So I want the longest chain to be the parent chain, which in this case is 8 long. This group here has 1, 2, 3 bends in it, meaning that this is a propyl group coming off of our parent chain. When we go to name the final organic molecule here, we would name all the groups in alphabetical order. I only have a propyl group, so that propyl will come first, and it's on the 4th carbon, so we can show that location. Then I have 8 in the parent chain, so that would be an octane chain. We do have that aldehyde, however, at the end, so we're going to take the E off and change the ending to Al. Say I were to have another group here, say on that one, that is only 1 carbon, 1 stick represents 1 carbon. That would be a methyl group, and I would have had to add that first, 7-methyl, because this would be in alphabetical order. Methyl would become before propyl. Our numbers are separated with our letters by a dash, and then 2 numbers would be separated by a comma. So if I had another methyl group on that same 7, I would put 7, 7, and anytime you have 2 of the same group, we would use the prefix di. So a dash between numbers and letters, a comma between 2 numbers. That's how you would go from the drawing to the name for aldehydes. Let me know if you have any questions.